Hi everyone, Rohith here. Welcome to CADverse. This is the second part of the knuckle joint tutorial. In the previous video, we completed the first component of the knuckle joint. In this tutorial, we will go through the remaining components of a knuckle joint. Let's get started. Click on this icon to hide the body from the workspace. You can also use the space bar in your keyboard to hide or view the body from the workspace. Now, we will move on to the eye end. See how to model it in a simple and clear way. To model this, you should start with a 2D drawing. These are the two orthographic view of an eye end, front view and top view. Here, I selected top view to start the drawing, because it clearly represents the object's main profile. To get started, create a new body from the task panel. A new body will appear in the model tree. Right-click on the body and select Rename to change the name of the body if need. Click on Create a Sketch and select X, Y plane as a top plane to draw the sketch. Draw a circle of 24 millimeters by using the Center Circle tool. The center of the circle is assigned with the origin of the axis. Select Create Arc by Center tool and draw an arc like this. Select the Line tool from the toolbar and draw a horizontal line starting from the end of the arc. FreeCAD apply constraints automatically to the sketch. You will notice that there is a small horizontal line, indicating that the line is a horizontal line. Continue the line vertically, looks like approximately it's symmetric to the x-axis. Finally, joint the two ends, followed by a horizontal line. To stop using the tool, right-click on your mouse, or simply pressing Escape key on your keyboard. Rough sketch is now completed. This is the time to apply dimensions and constraints to the sketch. As always, geometric constraints have to be applied before the dimensional ones. It's reduced the number of dimensions required for the sketch. This line doesn't look like horizontal. To make this, select the line and apply horizontal constraint to make the line horizontal. Make these two points vertical. Select the both points and apply vertical constraint to achieve this. Now, the geometric constraints have completed. Next, we have to give dimensions one by one. The diameter of this circle is 24 millimeters. And the radius of this arc is also 24 millimeters. The distance from this point to the y-axis is 86 millimeters. One input is still there to make it fully constrained. To do this, give the dimension to this vertical line. Select the dimension tool and give the length 28 millimeters. Now, the sketch is turned into entirely green, meaning that it's fully constrained or fully defined. Since your sketch is fully constrained, go back to the Part Design workbench by clicking this corresponding close icon. Find the Pad tool from the right menu and click on it. This will turn your sketch into a 3D object. Set the length to 28 millimeters. Don't forget to click this checkbox. This feature allows you to extrude the sketch symmetrically about the mid-plane, so the both side of the sketch is perfectly identical. Click OK to continue. Now, the primitive shape of the body is modeled. The next step is to model this transition feature, followed by a chamfer and fillet. And this shaft, finally, this chamfer. To do this is the same procedure we have done in the previous fork end tutorial. If you are skipped the first part of this tutorial, please watch it to learn about this. Link in the description below. You can find the engineering drawing file in the description below. Congratulations, you have completed the eye end of a knuckle joint. The next part is to be drawn is that the knuckle pin. The knuckle pin holds the two parts of the joint together and allows them to rotate relative to each other. It is simple in design, consisting of a cylindrical component with a head on one end and a cross hole to accommodate a taper pin. To model this, you should start with the 2D sketch. This is the front view of a knuckle pin. Only one view is enough to model this part, because it clearly represents its primitive shape. Now, let's see how to do this. Hide the part by clicking the eye icon and create a new body. Right-click on the body and click Rename to change the name of the body. Create a new sketch. Select the appropriate plane to draw the sketch. Here I selected XZ plane, which most useful plane to model almost all the parts. Draw half of the front view here. Then the revolve feature in FreeCAD is used to create a 3D solid by rotating the 2D sketch around the vertical axis. Let's see how to do it. Draw the rough figure of half of the front view here. Give the proper dimensions as shown in figure. Here, the diameter of the head is 38 millimeters, so take the value of its half. We define the dimension using a formula like 38/2 instead of the fixed numbers. Sometimes this is easier because we don't need to calculate manually. The height of the head is 12 millimeters. And the pin length is 80 millimeters. Now the sketch is fully constrained. Close the sketch by clicking the close icon. Find the revolution feature from the right menu and click on it. The revolve operation turns the sketch around the vertical axis, resulting in a 3D solid object. Here, you should specify the axis about which you want to revolve the sketch. By default, FreeCAD set to the vertical axis. Click OK to continue. The next step is to model this cross hole. Let's do this. FreeCAD restricts sketching directly on curved surfaces because the sketcher is designed to work on a 2D planar reference, not on non-planar geometry. So, we need to select a plane to draw the sketch. Go to the toolbar and select the Create Sketch tool. FreeCAD asks you which plane you want to sketch on. I choose the XZ plane to draw the sketch. To view the hidden axis for the reference, go to the toolbar and select the View Section tool. Draw a circle here. The center of the circle is aligned with the vertical axis. By using the External Geometry tool, select bottom end of the pin for the reference. Diameter of this circle is 5 millimeters. And the distance from the end of the pin to the center of the circle is 10 millimeters. Close the sketch. Since the sketch is inside the solid body, change the draw style to wireframe mode to make it visible. To do this, select the Draw Style tool. Under this drop-down menu, select the wireframe mode. Select the normal mode to go back from the wireframe view. Select the pocket feature from the right menu. Turn the dimension into Through All feature under this drop-down menu. And also make it symmetric to the plane by click this checkbox. We have successfully created a cross hole to accommodate the taper pin. Now, we'll finish the model by creating fillets on the two ends of the knuckle pin. Hold the Control key and select the both edges. Select the Fillet tool from the right menu. Specify the fillet radius here. It's 3 millimeters. Click OK to continue. We have successfully completed the knuckle pin. The next part is to be model is that the collar. Let's do that. Collar is a circular flange provided on the knuckle pin to prevent its axial movement. It acts as a stop element that keeps the component in its proper position. This is the orthographic view of collar, front view, and top view. The top orthographic view provides the correct reference for creating the base profile. Let's check it out, how to do it. Hide the knuckle pin from the workspace by clicking this eye icon. And create new body from the task panel. To change the name of the body, go to the model tree and right-click on the body and select Rename. Create a new sketch from task panel and select the plane. Here I select the top plane to start drawing. Click OK to continue. Draw two concentric circles here as shown in the figure. The centers of the circles is aligned with the origin. Diameter of the inner circle is 24 millimeters, and the outer is 38 millimeters. Exit from the sketch by clicking the close icon. Use the pad tool to extrude the sketch up to a defined depth. The depth is 12 millimeters. And also make it symmetric to the plane by click this checkbox. Click OK to continue. The next step is to model this cross hole to accommodate the tapper pin. To do this, select the Create Sketch tool from the toolbar and select the XZ plane to draw the sketch. It's the same process that we have done on the knuckle pin. The reference axis is now hidden inside the body. To make it visible, click on the View Section tool from the toolbar. Draw a circle of diameter 5 millimeters at the origin. Close the sketch and select the Pocket tool from the task panel. Under this drop-down menu, change the type into Through All, and also make it symmetric to the plane. Click OK to continue. Now, we have successfully completed the collar. The final part, which is to be modeled, is that the taper pin. A taper pin is a small conical pin inserted through the hole at the free end of the knuckle pin. Its primary purpose is locking and securing the knuckle pin in position. It is simple in design, consisting of a cylindrical shape, having the diameter of 5 millimeters and the length of 44 millimeters. Let's check it out, how to do it. Hide the body from the workspace. Create a new body, change the name of the body from the model tree. Create a new sketch from the task panel and select the drawing plane. Select the XZ plane to draw the sketch. Draw a circle of diameter 5 millimeters here. Close the sketch. By extruding the sketch using the pad tool, resulting in a cylindrical shaped taper pin. Specify the length of the pin here, it's 44 millimeters. And also make it symmetric to the plane. Click OK to continue. We will finish the model by applying fillets to the both edges of the tapper pin. This makes more realistic. To do this, select the both edges with the help of Control key. Apply fillets from the right menu. By default, FreeCAD already set the radius to 1 millimeter. Click OK to continue. Congratulations, we have completed all remaining components of a knuckle joint. The parts is now ready for the assembly. We will continue the assembly session of the knuckle joint in the upcoming videos. If you guys have any doubts, please comment below. Thank you for watching.